Hello, good afternoon and welcome everybody. I'm James Devon. I'm super excited to see you all here today. Please let us know where you're dialing in from, what you do, and type in the chat box with your information. There are three ways you can engage today. Most of you will have already discovered the chat function. We recommend you change the audience to say all panelists and attendees so you can interact with each other too. If you have a question for the panel, please put it in the Q&A box. We recommend you use the Q&A function because we'll not be checking the chat for questions. So remember, questions in the Q&A box. You should also be able to like the questions that are your favourites, and that makes sure we answer the questions that you want answered. So remember, questions in the Q&A box, go in there and like your favourites. Please let us know what you do in the chat box, questions in the Q&A box, and interact in the chat and comments on LinkedIn. Just a reminder, this session is being recorded. You can read the running order here. The importance of logistics has become even more apparent to us all in the last year. So for us, there's never been a better time to talk about innovation that can improve productivity in logistics and the challenges of dealing with the change needed to implement them. Logistics is a rapidly evolving industry that's a real force in driving digital transformation taking. We're lucky to have a great panel with decades of experience in logistics and connectivity. And as we go through today, we will focus on lots of new technology that's on the horizon, how to ensure adoption of that new technology, what underpins digital transformation and everything being online, i.e. connectivity, the pros and cons of Wi-Fi and private 5G networks as connectivity solutions in warehousing, and we've got case studies we can talk about as well. And then we move on to tactical connectivity solutions that can be rapidly deployed for when warehouses need to be up and running very quickly, whilst also providing long-term connectivity resilience. Each session is going to be around 13 minutes. So let me introduce the panel. So I'm Director of SD-WAN and Edge Computing Electronic Media Services. And prior to that, my careers included working at Panasonic and Thomson Corporation, which is now Thomson Reuters. I've been involved many times in disruptive and first-to-market solutions, most recently with secure networking solutions for live broadcast, moving vehicles, and the security and defence market. Mike Flynn has over 30 years experience in the logistics industry, and he's seen the good and bad of implementing technology change in general management, operations, business development, and supply chain consulting roles. For the past 20 years, Mike was the Business Solutions Director at GIST Board, directing the development and implementation of new supply chain systems and processes. Mike has a technical background in engineering and software development, coupled with years of operational line management, delivering organisational change through enabling people to exploit new technology. Stephen Muldowney has over 20 years experience of working with CSPs in the fixed and mobile sectors and helping them deliver new advanced services and dealing with their pain points. Stephen has deep understanding of multiple markets as well as solutions from in-home and mobile devices, video, access voice, wireless RAN, small cell, etc. Lawrence Walker is also the Director of Electronic Media Services, and prior to joining Electronic Media Services, spent 15 years working in the UK and internationally for the Dutch multinational Philips Electronics. At EMS, Philips works with clients in creative, construction. Lawrence works with clients in creative, construction, retail, logistics and broadcasting industries, as well as public sectors delivering connectivity to remote and temporary locations. And now we're going to move over to Mike for his session on dealing with adoption challenges. And remember, questions please post in the Q&A. Mike.
Thank you very much, James. I'm going to be talking about some of my experiences of implementing warehousing technology and achieving engagement with the workforce in particular, we have a range of very, very exciting technologies that we'd like to implement. They're driving things like improved productivity, improved accuracy, but also more recently, things like improved visibility for our customers into what we're doing, enabling new services. And from the perspective of the teams implementing these new ideas, they're exciting, innovative uses of technology where we're looking at driving a great deal of benefit very quickly in the organization. However, we often find that the workforce feels a bit like they're being assimilated. They have extra work, fear of change, fear of what this means for their colleagues' jobs. And what I'm going to talk about is how we overcome that. All of that drives us to often experience a resistance to change. And in that resistance, there are two things to consider. One is what people say, and people will be saying things like, that change can't be done in the time that is available. The new process is too difficult for me, the customers, the suppliers, but somebody in the system. The equipment won't work or doesn't work. The new process can't be executed in the time allowed. So I'm not actually going to be able to push all of the buttons and do the faff that I think I'm going to need to do in the time that I'm allowed in the current process. And there's always the good, it's not in line with some policy as a reason to not do things. But what people really mean is so often it doesn't work. So we need to be very conscious that things that work in the lab or in the marketing environment might not work at 3 a.m. in a freezer or in the rain. Or equally often, we ask people to do something that is often more difficult in the very immediate area without an understanding of the upsides to other people or downstream. As data becomes more and more visible, there is a fear of unreasonable accountability. Is my work going to be evaluated too harshly? Am I going to have too much of an increase in productivity? There's also the underlying fear of learning the new way of doing things. And related is a concern that makes things, the roles less interesting or less secure. When change management practitioners talk about how to overcome resistance to change, often they use the burning platform metaphor, which is to create, or fairly often to find oneself on a burning platform for change. The advantage of this is that it creates an imperative for why the status quo isn't achievable, why we have to move to a new world. However, burning platforms are normally a thing to avoid, and normally it's very, very difficult to create that environment safely. What I'm going to talk about is how to drive change, but without having that burning platform forcing change. So how do we create a safe burning platform? And one of the things that I found, particularly with technology, is to engage the developers and the project sponsors with reality. Have we actually used this technology? Have we used it in the production environment, in the context of what we're going to do to roll this out? So have we actually stood there in the gear that the driver uses, the warehouse man uses, the call center operator uses, in the dark, in the rain, with the response times and the work pressure to confirm, yes, this actually does work and it works robustly? We can then move on and engage the front line with the reasons for change. And I've always found that building empathy for who's going to benefit or who's suffering today that we will remove the suffering from. Doesn't have to be the worker who's changing, but they do need to engage with somebody in the process, how this change is going to make their lives better. Or how is today's change going to help the workforce's lives tomorrow? Or alternatively, is there an impact on customers that will improve their service or their experience? Does it enable us to grow the business? So why is it that we're going to make this change other than the boss said so, or we're going to make the company more profitable? It's looking for something that will engage the people who are changing in why it's good for them to change. Often change is driven by customer demand, and helping to put your team into the customer's mind and why it's so important that this change is delivered for them tends to help to motivate the change. And if you can widely share the perceived benefits of change throughout the organization, you can build momentum behind why it's important to make this change. And similarly, if we reflect how responding to the customer demand improves either the services to our customer, the sustainability of our jobs, the interest in the role, the growth of employment opportunity, whatever it is that helps to engage, once again, the people who are making the change with how to move forward. And finally, is to remove the handrails. Once you've made a commitment to a change, make sure we migrate from one process to another. Avoid layering processes. Make sure that there's enough equipment, training, bandwidth, resilience to prevent any excuses for needing to go back to the old way. However, like all technology changes, make sure there is a clear and viable fallback plan. You need to have a plan for what happens if something doesn't work. What I'm now going to do is just look at a quick example of taking these principles and applying them to a relatively straightforward change. So the situation is increased fresh product is driving late volume changes. So people are making late changes to orders for an overnight retail food service operation. And that's creating cost and service challenges within the supply chain network. So the requirement is we need to be able to move orders between routes right up to loading time. So we need a much more dynamic environment in the warehouse. The loaders clearly need to know and to be able to validate the orders to routes, and the drivers need to know and validate the cages to drops in an environment where every day there will be a different sequence of routes that are being undertaken. The solution is a dynamic routing throughout the day and a RF tag loading system and delivery system so that each cage is uniquely identified and can be loaded onto the appropriate vehicle at the last moment and automatically generate manifests, be coupled with the routes, and provide the information to the driver of what he's going to need to do en route. So the way we drove this change is first verified, as I said, the technology in the live warehouse environment. And in this particular case, the first technology proposed had excessive latency, which was the developers had fairly quickly concluded was never going to be achievable. We moved to another technology that didn't have the latency challenges. We couldn't have a paper fallback. This had to work all of the time, and we had to be clear about the resilience of the solution, that if the solution wasn't working, the operation wasn't working. We engaged the staff and the customer groups of why we needed to be so much more dynamic on the volumes. Fortunately for us, there was the current situation provided a problem for the drivers in terms of the economics of the driving side of the business, but also their lifestyle, where their shifts were changing. They didn't know whether they were going to have a long or a short route. So there was a great deal of pain in that area, which the warehouse was able to develop empathy for. And the drivers really were desiring to know exactly that everything that was supposed to be on the vehicle was on the vehicle, and that they had delivered everything correctly. So that allowed us to engage the drivers in communicating their challenges of in the middle of the night, in the rain, in the dark, near a nightclub turfing out at 2 a.m, how to find and quickly assemble the delivery from the existing paper solution, and also them to communicate their complete reliance on the loading team using the new system. For the warehouse, we took on board the challenges of there isn't going to be enough time. We knew that once we were through the change, there would be more than enough time, but we brought the pick early to provide lots of buffer time in the operation. We engaged in extensive training, an important sort of capital commitment of early equipment delivery so that people could see the mountains of equipment available that were ready to roll, and gave confidence that we were serious about delivering the necessary infrastructure to make this a success. The change was a success. The workforce bought into the ideas, delivered the change, and we delivered the economic case behind that, the service case, and moved on to other challenges in the industry. I hope that that gives an explanation of a different way of approaching change, more engaging people in why the change is good for them, rather than creating the burning platform motivation of we have to change. Thank you very much. Now I'd like to hand back over to James.
Thanks, Mike. Great session. Remember to post your questions in the Q&A box, but just a summary of the points that I made a note of. 1, expect resistance to change. 2, folks may feel less secure. 3, create a safe burning platform by engaging with people, having a reality check and giving them a real reason for change. And 5, have a fallback plan. So really interesting stuff there. Next up, we have Stephen to talk through the pros and cons of the use of private 5G and Wi-Fi in warehousing. Stephen, over to you.
Good afternoon, everybody. My presentation today covers 4 main areas. Firstly is looking at what the benefits 5G brings to Industry 4.0. Secondly, why not only Wi-Fi for Industry 4.0, and particularly logistics and warehousing. Third, Industry 4.0 and 5G, what does it really mean? And finally, just to pick out some sort of use cases within the logistics warehouse area and some actual ROI deployments that have been happening within the industry to date. Next slide, please. So firstly, what I want to look at is really what does 5G bring to Industry 4.0, and particularly warehousing and logistics. There are 6 sort of main sort of metrics you sort of measure in this space. The 3 that I'm really going to focus on that have the most importance in terms of the use cases within the warehouse logistics are speed, latency, and capacity. And what I've done here is basically pull out what that means from a indoor perspective for logistics or warehousing. So it would be slightly different if we were talking about a outdoor network. So in that case, what we're talking about here is basically speed. So that's in the sort of terminology used in 5G, that would enhance mobile broadband. And that really brings higher average speeds around 100 megabits per second, up to a peak of 2 gigabits per second. Of course, again, you get faster in an outdoor 5G network. And that's roughly about 2 times faster than the average speed that you get today from existing networks. The second one is latency. And latency, again, sort of the 5G terminology it used is called ultra reliable low latency communications. And what it gives you is basically less than about 1 millisecond on an air link, or realistically, what people really measure here is the end-to-end. If I start to do something, how long does it take to basically for that action to actually take place? And that's roughly about 10 milliseconds end-to-end in a 5G network. With 4G networks, then what we've got here is basically the latency is roughly about 10 seconds on an air link, and then about 50 seconds in terms of the end-to-end, which is again the most important bit in this scenario. And capacity. So capacity really means how many devices it's going to have within that network at any one point at a time. And then again, the terminology is massive, used in 5G is massive machine type communications. And roughly, again, for an indoor radio, it's about 128 active users per radio, and that's roughly about the capacity of about 4 times what you can get today. There is reliability, security, power, and location, but they are less relevant in this environment. Next slide, please. So when I say why not only Wi-Fi for Industry 4.0, is because 5G is not about replacement for Wi-Fi. Wi-Fi will still continue to be a really strong and relevant technology for use in this industry. However, when you're looking at the technology you select, then what you really got to look at is basically, is that technology fit for purpose in terms of what I want it to do? And in terms of Wi-Fi, then it has certain 5G has certain benefits over Wi-Fi rather than being negative about Wi-Fi itself. So in this sense, what we're looking at is sort of the main area, which is security. So Wi-Fi has less policy control, and poorly connected devices allow you to basically get onto the network. In terms of handover, then it's not secure. It's a handover between the Wi-Fi cells, as in the 5G or 4G network. Wi-Fi does suffer from interference and congestion and from unlicensed spectrum within that environment. So there's a push to talk or any other sort of licensed spectrum used, then it will interfere with the Wi-Fi. From an operation and maintenance perspective, then the management of the network overall, then there's less policy control or ability to prioritize and manage traffic flows. Mobility, then again, we talked about that there's the Wi-Fi is a sort of closed network, and there's where within the mobile we can move between the public and the private. That mobility between the macro and micro environments is possible. Again, we talked earlier about the latency, bandwidth, jitter. So basically, just got this. The difference about latency in the 5G world is it's known, it's a stable latency. It's fixed, whereas in the Wi-Fi, then it can be unpredictable, which means that's not something that the networks like. And finally, the number of access points is 5 times greater in terms of Wi-Fi than compared to 4G, 5G. Okay, next slide, please. So what you've probably heard when people talk about sort of 5G and a sort of Industry 4.0 perspective is the use of the word private mobile networks. Private mobile networks is a growing area within warehouse and logistics. And what this is basically a completely private closed network that is separate to the public network. The public network is what traditionally the mobile operators will provide and is both indoor and outdoor. But in this case, what we're talking about here is private mobile networks in an indoor and outdoor perspective, closed networks. And this is a terminology I've borrowed from the guys at Ethernet. And what they define the two sort of key markets or segments for mobile private networks as being the square mile network, where you're just providing basic coverage, mobility, and critical communications. The square feet networks, which are ones where you need a solution for high security, congestion, content control, etc. So what
like we've
you
just
can use Wi-Fi and not mobile broadband. Next slide, please. So here, what I want to talk about now is basically taking some of that technology and those use case and those benefits of that technology and applying it to an example logistics warehouse scenario. And in this case, there's a couple of sort of really key use cases. Firstly is basically in terms of the truck. So what we're talking about here is basically where you've got visualized parking. So using the existing 5G network to basically implement some visualized parking and status and scheduling. So you can use so you don't get congestion in the yard. You can basically do just-in-time delivery necessary for that when that part or that element needs to be brought into the warehouse. You can better schedule the resources in terms of actually within the actual warehouse, and also of your partners from a delivery perspective. The next one is the forklift and AGVs. This is the most critical and the key use case. Here, what we're talking about is this is not about new technology. AGVs, automated forklifts, are already present within logistics and warehouse situations. However, they're limited in terms of a couple of things. First, they're limited in the number of you can have within the environment, because you've got limited ability to control them. Also, you need to keep the distance between them quite larger, because you've got less ability to control them. The second bit is about where they can go. They're generally stuck to a limited area, defined space. In the future, what we want to do is add in where these AGVs have no limit to where they can go within the factory or the logistics or warehouse or even the factory itself, but also that there's more of them. With 5G, what we bring is that control, because you've got a low latency and the high bandwidth to be able to control the AGVs much tighter. So what that means is you can have more of them and they can run more close to each other, because the ability, if something goes wrong or a human steps in front of them or something falls over in front of it, you can react to basically stop them before any incident actually occurs. And then the final key use case is in terms of the assets. And here what we're talking about is basically asset tracking. So in a warehouse, one of the benefits I talked earlier about the warehousing is a number of devices you can track. So what we're talking about here is now the ability to track more devices within in your environment, and knowing exactly how many you've got, and on that basis you're able to then basically get them delivered just in time. You're able to then not losing track. I think I read somewhere that there's 2.5 billion of money is lost globally in terms of lost assets within this environment, in terms of warehousing logistics. So ability to track this and know what you've got and order it just in time is going to be the ability to use the same network to be able to do that with everything having its own tracker. Next slide, please. So for a final slide, what I really want to talk about, I've really talked today about the sort of use cases and the benefits to technology, and where and what the underlying technology is and benefits it brings. And what the message I want to get across here is that basically this is not about futuristic technology. This technology is being deployed today. Logistics, so warehouse and transport is the 5th largest vertical that will see the biggest benefit from 5G. Today in the UK, there's 2.2 million people employed in this sector. It's about 8% of the workforce. So it's an important one, and we're already starting to see this deployed. So here, in terms of here's 4 use cases where it's real world deployments of this 5G. Some of those use cases I've talked about today. So Dyson Krupp have basically used mixed reality and in their warehouse, and have seen a 20% boost in the order efficiency in their warehouse through what they're using, basically that vision picking using the 5G network. Sonic, a large industrial organization from China, has basically has been using AGVs, but they've been laser guided ones, and now moved to controlling them via 5G. And what they've seen is basically a 10% cost saving compared to their legacy technology, and that the cost of those is much less compared to that existing technology. So they've seen a real benefit in terms of moving away from what their legacy to the new 5G network to control their AGVs. Robotechnics have been using AGV scheduling and faults for emergency response, and have seen a 30% increase in production efficiency and 40% reduction in labour costs by moving to this. And then finally, here is basically it's a tier 1 German automotive factory. Germany has basically moved to using its new 5G network to track assets, to locate, track equipment, and sort of do general work in progress activity. And what they found is basically the move into that has become the more reliable, efficient asset tracking, which leads to a general overall equipment effectiveness. And secondly, roughly, that they think overall this is about efficiencies of 0.8% per factory. Now, that doesn't seem a lot, but these factories are super efficient today. And they generally work at about a 2% savings, that they look to, efficiency gains each year. So something that can get almost 50% from doing one thing is a huge step forward for them and has a massive impact on their sort of their capex and opex costs going forward. Next slide. So yeah, and just basically to say thank you very much. It's a pleasure for me to present this, and yeah, look forward to your questions and answers. And please raise them in the Q&A section of the webinar.
Great, fantastic. Thank you very much indeed, Stephen. Great session there. Just to summarise the points that I made a note of. So private 5G is not here to replace Wi-Fi, but to complement it. Private 5G is already being deployed today, and you gave the real world ROI examples. The key benefits of private 5G in warehousing is speed, low latency, and the capacity. The AGV's example was that 5G gives you more flexibility, no limits on movement, and the ability to have more of them. So they're the key things that I made a note of. So far, we've looked at how to deal with adoption. We've looked at connectivity options within warehousing in terms of 5G and Wi-Fi. So now we're going to move on to Lawrence to share how rock-solid instant secure connectivity can be provided at temporary warehouses and locations. So remember, questions and answers in the Q&A box. And over to you, Lawrence.
Thank you, James. Good afternoon, everybody. So indeed, as has been said, my presentation really focuses on what is, I think, quite a pressing problem for many in the logistics industry, which is the provision of acceptable internet connectivity at new and temporary locations. Next slide, please. So obviously the default choice, which I think probably many logistics company IT departments will instinctively reach for, is really a lease line solution, a fiber lease line typically. And that's obviously a familiar solution. It's typically reliable with predictable performance. But, and these are really the issues currently in the pandemic environment, lead times to procure fiber lease lines are long and extending, so quite often 90 to 180 working days. Lease line can be expensive with excess construction charges to actually get the fiber from where it is present to where you require it. That may well involve some way leave issues in terms of getting it across land to a warehouse, and particularly maybe an issue in the current environment. Contractual tie-ins on lease lines are often up to 36 months, and that may well be not really acceptable for something that's a short-term contract for, let's say, 6 months. Next slide, please. One option, I guess, is lease line plus a microwave network to provide connectivity to a number of different sheds at a given site. It's obviously a good and typically lower cost way to connect multiple sheds on a large site. Still requires, however, a fiber point of presence at site, and it will require professional assistance to set up. Signal path requires near line of sight, and that's obviously an issue in terms of ability to guarantee at a given location. Next slide, please. One thing that people could reach for, of course, is a 4G router solution. So a standard 4G router is easily provisioned, it's quickly provisioned. It can normally be set up by the user's IT department or by the user themselves at site. Relatively low cost, and these days there is mobile network, typically 4G coverage at most locations. Having said that, experience suggests that performance or speed is not always satisfactory for these sorts of devices. There's a question of mobile network service resilience. If you're dependent on one particular mobile network, then that's obviously a clear point of failure, a potential point of failure. You may encounter things like mobile network monthly data limits, which may well be an issue for running a large enterprise-sized warehouse activity. And then there's the issue of how best to integrate with a corporate IT network from the point of view of trying to run VPNs and meet security requirements. Next slide, please. The solution that we are able to offer as electronic media services is the IMO OptiBond solution, which actually allows you to bond 4G connections, plus also if you require perhaps WAN connections. Those WAN connections would typically be some form of fixed line connectivity. So if it's not practical to run a fiber leased line, but you are able to provide perhaps some ADSL connections quickly to a site, then those can also be aggregated as part of that bundle of bonded or aggregated connectivity. So the solution, as I say, bonds and aggregates multiple services. It allows for diverse services, so that might be different 4G mobile networks and the plus of wired networks also, which obviously is good for resilience and reliability. The mobile networks we're typically working with increasingly do offer unlimited data tariffs, which takes the issue of data limits out of the equation. And our managed service, the bonding service, provides a static IP, which gives you the facility to easily configure a VPN and allow for integration into a corporate IT network. Our proposition includes a mobile coverage survey to establish that there's sufficiently good 4G coverage at the location. We supply the router pre-configured so that it is easily set up at site. The service provides outdoor 4G aerials, which you can put on top of the shed so it gets outside an environment where there's a lot of metal, which obviously isn't good necessarily for any radio-based technology. We supply the SIMs and we obviously provide that managed bonding service and a support wrap. The product easily allows you to connect your Wi-Fi access point system within the warehouse, and from practical experience will support large numbers of hand scanners plus back office desktops, etc. Next slide, please. I won't bore you with too much technical detail. The back of these kind of products is always the most interesting. So we have really two products which are appropriate, I think, for this sector. The 310 product would allow you to aggregate up to 6 4G services and up to 4 fixed line services. Next slide, please. And the smaller 210 device would take up to 4 mobile SIMs plus 1 fixed line service. So that might be an ADSL service. Next slide, please. Just a little bit about us. So as a company, and obviously both myself and James are employees of the business. Business was established in 2000. We launched what you might describe as the first generation bonded router product back in 2006. We have a focus on the logistics industry, so clients include DHL, formerly UK Mail, Clipper, Fuller's, and DB Cargo. And go back on again, if that's okay. Thank you. So the applications are obviously not only in logistics, but also historically in construction, retail, television broadcasting, and the running of events, pretty much anywhere where good, solid, reliable, rapid internet connectivity is a must-have and can be provisioned quickly. As a business, we also are active in delivering fiber to the premise and microwave networks, and our software business is involved currently in a distancing solution for safe management of workers in crowded environments during the present pandemic. Next slide, please. Again, I won't dally too long over this, but you can see there's a diverse range of clients across many sectors. You'll recognize let's say some people from your business, your industry, I should say, in that slide, but also some retailers, construction companies, and government, all of whom have that requirement for rapid site setup, rapid connectivity in often difficult circumstances, or where there's simply a lot of time pressure and maybe economic pressure as well. I think that's the end of my presentation. I'd like to hand back to James, and obviously I encourage everybody to ask questions that will when we get to that point of the conversation this afternoon. Thank you.
Great, thanks very much indeed, Lawrence, for that. So just to summarise on some of the points that you covered, in terms of getting connectivity to a warehouse quickly, fixed lines has long lead time. Simple 4G routers are not always reliable if they're using a single network and may not have enough bandwidth. bonding solution increases reliability and bandwidth. Don't need to worry about overages because you can now have unlimited data SIMs, and it's easier to integrate into existing IT infrastructures. I think that's very, very useful information. So we've got some great questions so far, which I'd like to put to each member of the panel. And so let me just come to the questions that I've got here. So Stephen, I'll start with you if I may. What technologies do you see being implemented first in warehouses of the future?
Well, of course, James, I would say 5G. In that, I think it's the key sort of next technology. You know, I think Wi-Fi 6. You know, those are going to be the two sort of key fundamental technologies that are going to be deployed in this space over the next couple of years. And there's going to be a lot of sort of competing sort of talk in the industry around how, you know, what Wi-Fi 6 brings compared to 5G. So I think that's sort of the key sort of area of debate for the industry going forward.
Great, thanks very much indeed, Stephen. Mike, so same question. What technologies do you see being implemented first in warehouses of the future?
I think two related technologies. One is much more of augmented reality to help in identifying and controlling warehouse processes. And similarly, some AI vision technology for helping to validate the processes have been successfully accomplished, both of which are going to drive a tremendous increase in the need for bandwidth and for smaller operators to have high bandwidth connections.
Great, thank you very much. Lawrence, same question. Which technologies do you see being implemented first in warehouses of the future?
So I think if we talk really about warehouses of the future, I would really have to duck that question and defer to Mike and Stephen, who I think are probably better qualified than I. In terms of warehouses of the present, inevitably, I would have to say I think bonded 4G is a good, strong solution for getting internet connectivity in that kind of difficult to serve location, new location, temporary location. Where lease lines, the sort of the go-to option really aren't practical for economic reasons or just in terms of the available timescales.
Okay, thank you very much indeed for that. Next question I've got is one from Dave Barber. So thank you very much indeed for this. Will EMS be launching a 5G solution? So probably best if I direct that to you, Lawrence.
Or I could always bat it to you, James, because we both work for EMS. So yes, the answer is yes. We will have a 5G solution. I think that's probably, let's say, a quarter or so away from a timescale point of view. What I would say is, of course, a 5G solution really has value where 5G is available as a service. Now, obviously, Stephen has talked about private 5G, so 5G within a warehouse. Obviously, the public mobile networks, the Vodafones and the EEs and so forth, are the guys who will really dictate how present 5G is as a public service in the wider world. And clearly, there are locations where that is already the case or will be the case fairly quickly. But if you like, the inherent nature of 5G means that there will, for the foreseeable future, be many areas which are really not addressed because of, if you like, the underlying radio limitations of high frequency radio-based networks. So I don't know if that answers your question, Dave. I think it will be a mix, but clearly we will have a product that meets that requirement and is downwardly compatible to the earlier 3G and 4G standards where it needs to be.
Okay, thanks very much, Lawrence. So next question to the panel, what would you say is the single biggest roadblock to rolling out new technology? So Stephen, over to you.
Yeah, well, I think in the area that I've talked about, then I think it's the return on investment is not as obvious and easy to calculate in some regards. So I think what you've got there is one of the sort of key areas. I think there's also still sort of a lack of awareness of the technology. You've got the OT world and the IT world, and in the warehouse logistics area. I think then also what you've got around it is basically that you've got, you know, a lot of people are making investments in some of these the Wi-Fi technology, or have made this, and then are, you know, are worried about making investment in a new technology area. So I think these are all sort of key challenges that there. And then finally, sort of is thing around spectrum. So it's only recently in last year that Ofcom provided private mobile spectrum in the UK. So there's a little bit of delay while the vendors, both sort of, you know, the network, but also the end devices, bring out compatible equipment to work in the spectrum. So at the moment there is a lack of a lot of different vendors working in this space, but that will grow over time and will removed.
Great, thank you very much, Stephen. Mike, same question, which is probably one of your sweet spots here. Single biggest roadblock to rolling out new technology.
I think there's a tremendous amount of really exciting technology, but as it develops, not all of it is quite ready for prime time. So it's to make sure that what you're looking at is actually suitable for the task that you have at hand, and then making sure that you have an excellent engagement program to deliver that change within your organization. And that tends to be where things fail more often, is in that engagement.
Thanks very much, Mike. Lawrence, single biggest roadblock to rolling out new technology.
I think inevitably, probably people. I think Mike had already covered that or addressed that by saying, obviously, you have to carry your people with you. They can easily break any new implementation if they're minded to do so. So I think really Mike has addressed that in a very comprehensive way.
Great. Okay. Thank you very much. So I've got the next question here is, how does private and public cellular interact in a logistics environment? So probably one for you, Stephen.
Yeah, that's fine. Yeah, no, I think they I guess about Wi-Fi being complementary. I think these are also complementary. So if I give an example of a Nissan, you know, in the UK they haven't done anything, but is an example of their factory that, you know, they're taking you know, a lot, you know, amounts of suppliers that are nationally based as applying into them, you know, and they want to be able to know, sort of track inbound goods, so they can see when they're going to get certain parts, you know, for their just-in-time production. So they will need then the use of the public network. So the public network is to be able to track the lorries, the actual individual components potentially, you know, that they're in. So and then when it comes into the sort of their warehouse or their logistics center, then it will move to the private network, and they will use it then to do, you know, that type of thing. Secondly, you know, then they've manufactured a car, comes out the other end. Basically, they've used the private network to control their robotics, you know, building the cars or the AGVs, delivering parts, the assembly line, etc. The car comes out. They could then, you know, that car has to basically probably sat in a holding pen for a while. Its software is out of date, so it needs to be updated. And so realistically, use the public network then to provide this new software update to the car before it goes out to the showroom. And I mean, ultimately, I think I once read that there's 20,000 plus car carriers move between the Nissan factory and the port in terms of delivery every year. So why can't those cars just deliver themselves to the port and drive themselves onto the thing? But that requires the use of the public network to be able to do that. So the public network is used for updating the software to the latest version before it goes out to the showroom, even before it's delivered to the customer, or it's basically driving itself to the port and on the boat itself, public network. So there's examples where you've got this mix of public, private networks where you need, maybe that sort of customer will eventually be using both to be able to do that. And you know, when the use case requires that sort of, you know, square square feet type network I talked about in my presentation, and that's where the private comes in. But if you're talking about other use cases, then then absolutely the public will be the sort of the best network to use in that case.
Great, thank you very much indeed, Stephen. So great answer there. So next question I've got actually is one for you as well, Stephen, which is it possible to cost out private 5G on a square meter basis in a warehouse?
Yes, absolutely. I mean, there's a lot of different factors that come into it in terms of you've got to start off with what are the use cases. So if you've got an asset tracking, then you might need less sort of radio network inside, because you're talking about coverage, but it doesn't need lots of bandwidth. It doesn't need low latency. So you might have less access points. But in a way you've got AGVs controlled and robotics, then or predictive maintenance in the factory, then you might need more access points. But once you sort of understand that, even without that detail, you can work out roughly how much area each of the indoor radio units covers, what roughly the capacity you've got, be needing, and then how much spectrum you've got available. Off the back of that, you can then calculate your sort of the radio. So yeah, absolutely. And ultimately a private mobile network is quite simple in really. It's the same sort of, it's the radio units, similar to the every see within their sort of office space, or today for Wi-Fi, they connect via either fiber or Ethernet, same as you would do Wi-Fi or with Wi-Fi access point. They connect through to a switch. They connect then to some core, that's either local or potentially is off premise in the cloud. There's not many elements to make it up. Of course, you need an overall system integrator to sort of put it together and then provide the managed service. But it's really a low OPEX type. Less CapEx than you imagine, and also then low OPEX in terms of it just sits there and continues to work without needing any much operation and maintenance. But yeah, absolutely, you can work it out on a per meter basis. In fact, we in my old role at Huawei, we had that calculated for each of the different scenarios: factories, indoor, commercial offices, railways, etc.
That's fantastic. Thank you so much, Stephen, for that. I really appreciate that. So I've got another question here, which is, can a 4G/5G solution replace a fixed line? I guess that could be one for you, Lawrence.
It sounds like it might be, doesn't it? And I think the answer is probably yes. Certainly from practical experience, we've seen that it's met requirements for a variety of our customers, including people who are running perhaps 100+ hand scanners off a system, plus office users. So I think in many circumstances it meets that requirement very effectively.
Well, that's great. Thank you very much indeed, Lawrence. So that's the end of the question and answer session that I've got. All the questions covered. I'd like to thank you all for joining us. Really appreciate that. If you've got any questions, you can contact us at sales@ems-uk.com. That's sales@ems-uk.com. We'll contact you shortly to provide the recording, and we'll give you a write-up of the event and send the slides through. We hope we see you soon. Thank you very much indeed for joining us.
Thank you. Thank you, everybody.
Thank you. Bye.
Thank you. Bye-bye.
Bye.